Welcome everybody. We are now in our final unit, Unit 6, Lesson 1. Congratulations, you've traveled through 5 units in Math 8 and your journey has brought you to what we call the Pythagorean Theorem. Pythagoras was an ancient Greek person, and the Pythagoreans studied math and philosophy. And in the Pythagorean Theorem, something special happens with a right triangle. So a right triangle is called a right triangle because it has one angle interior in the triangle is 90 degrees, which means it's a fixed angle, which means there's only so many triangles that you can build with the other two angles. A triangle inside interior angles, they always sum to 180 degrees, and there's 3 of them. So the triangle interior angles, there's 3 angles inside of a triangle, and they have to add up to 180 degrees. So if one of them is 90, then you have to have any other combination of the other two. It could be 89 and 1, 88 and 2, 87 and 3. The other two angles have to add up to 90 also, so that the 3 of them add up to 180. So let's take a look at our objective. In Lesson 1, we're just going to solve for what we call the hypotenuse. We're going to take a look at this triangle here of a right triangle, given the lengths of 2 of the sides. We call those legs. And then we'll check for reasonableness, but then we'll look at the converse of the Pythagorean theorem. So basically, if we have 3 side lengths given, will the Pythagorean theorem work? And if it does, then we have a right triangle. Okay. And why is it important? Why is the Pythagorean theorem useful? It's useful for a couple of reasons. It's useful if we want to find the distance diagonal between 2 points. On a grid, once we are diagonal instead of vertical or horizontal, once we're diagonal, we need a way to find the distance diagonally if we set up our grid with vertical and horizontal lines. And to find the missing side, if we have a missing side of a right triangle, so one of the 3 sides. So here is our triangle. We have our vocabulary here, legs and hypotenuse. And so here is a right triangle. So the right triangle is always going to measure we're going to use this symbol here for the right triangle, but in fact we want to use instead, we want to make sure we use red. So I'm looking for red here. It'd be best. It's best to use a red color for your right angle. And then you can see that there's angles here. This one is 90 degrees. So then we can have, let's say that this was, let's say that this angle was 40 degrees. Then this angle up here has to be 50 degrees. So we have the sides lengths, and we always go diagonal across the, from when we label our sides. This is angle C, so this is little c, is the hypotenuse. It's a big, complicated word. It means the longest side of the right triangle. It also is the side opposite the 90 degrees, the right angle. So then we always go opposite. There's capital A for the angle, which is 40 degrees. And here we would have little a, and diagonal from here would be little b. Okay, if we wanted to name these angles, we always use 3 letters. So instead of it being angle A, it's best to label this angle BAC equals 50 degrees. And let's name this angle ABC. Wait, I made a mistake. BAC is not 50 degrees. Oops. It's 40 degrees. And then BAC or ABC is 50 degrees. And then angle ACB, and we're labeling it with 3. ACB is 90 degrees. That's our right angle. Okay. And it says to measure a little bit. We could do a quick measure just for the purposes of how you would measure this. If I had to measure it in centimeters, the longest side should be the longest. It says 11 centimeters from 0 to 11. And that's AB, 11 centimeters. AC is 9 centimeters. And you can see all this in your book on page 410. And this looks like it's about 6.7 centimeters. So we obviously see that AB is the longest side. Okay, so that's the Pythagorean theorem. There are special numbers that make up right triangles. We call those the Pythagorean triples. So if I was to draw a quick sketch of a triangle that had sides 3, 4, and 5, it would look something like this. Well, I could just do it in centimeters, I guess. 3, 4, and 5. Notice you can't measure the 5, so you got to do the 3 and the 4 first. This was 3 and 4 and 5. That's a Pythagorean triple, the most basic one. Make sure you label your right angle. And if I had to give these my points, make sure that you always start with labeling the angle at the right angle as C. And then usually we give A as the smallest number, so this would be A, little c, capital B, little b. So the really important one is to get the little c and capital C. Mixing up A and B is not a big deal. There's another triple here, the 12, 13. Let's see if I can fit this one in. I'm going to go as far down as possible and go, well, I don't have to do that. I can go 5 here. 5, and then 12. And when I draw this, it doesn't matter on the measurement for the third side. This Pythagorean triple, again, find the right angle, capital C, little c. Then this is the shortest side, so we're going to call that capital A, capital B, little b. So we're labeling it correct, and then you just pop in the numbers. 5, 12, 13. The hypotenuse is always the longest in a right triangle. So now we're ready to apply what we call the Pythagorean theorem. It says that the square, if I was to go back to this one, if I was to draw a square here, let's just do a quick drawing of a square. Notice that the area here is 3 by 3, which is 9. Okay, and I draw this square. We can see that this is 16. So if I add 3 squared plus 4 squared, it adds up to, I'm just going to draw this right out here, a nice big square, 5 by 5, 1, 2, 3, 4, 1, 2, 3, 4. This square is 25. It's 5 by 5, 5 squared. So we've just proven that 3 squared plus 4 squared equals 5 squared if it's a right triangle. So that is what the Pythagorean theorem states. It states a squared plus b squared equals c squared. The hypotenuse, that's the key. It's isolated over here to the right. We call these legs. So this is a leg, and that's a leg, because they combine at 90 degrees, so that gives them support. And then again, this is the hypotenuse. So there's some key vocabulary to doing Pythagorean theorem, which brings us to the actual a squared plus b squared equals c squared. Again, the important thing, identifying the c, a, and b. So we go opposite. This is little b, that's little a. The Pythagorean theorem says square a plus square b equals c squared. We're just popping in the numbers. We have 9 inches for a, and we have 12 inches for b, and we're solving in the first lesson only for the easy one. So we're just doing 9 squared plus 12 squared equals c squared. And of course, PEMDAS. PEMDAS here. Exponents first, then you can sum it, and then you can take the square root. Oops, it's missing the word root. 81 plus 144 equals c squared. Now, if you don't know your squares, last unit in the blue notes we had them, but you can use the squared button. It's 9, and then it's x squared, or 9 times 9. And the same thing for 12 squared. Super fast. 12 squared is 144. Let's add those up. 144 plus 81, because that's what we do next. We have 225 equals c squared. Now, in order to find the square root, in order to find what c is, we're going to take the square root of both sides. Normally it's plus or minus, but we have a geometric shape here. We're just going to have the plus sign, but we'll do the answer. The square root button is here, so we'll hit square root 225. And this time we get an integer, which is nice. It's a Pythagorean triple, 9, 12, 15. 15 equals c, not c squared, just c. The squared's gone now, and we get rid of it. 15 equals c. Perfect. If you get a decimal answer, that's fine. You can round it to the nearest tenth. And finally, we get to the converse of the Pythagorean theorem. That says that if it's true, if you have a, b, and c, if you have the 3 sides of these are the 3 sides of a triangle, then it says if you put it into the Pythagorean theorem and it's true, then the triangle is a right triangle. So that's all we have to do is just put them in and test it. If a triangle is a right triangle, then a squared plus b squared equals c squared, and converse. If you put the numbers in and it's true, if this and true, then the triangle is a right triangle. Okay. So let's take a look at how this looks in an example. They give you 3 sides, 5, 12, and 13. Well, we just did 5, 12, 13, and we knew it was true. And plugging them in does show it to be true. Let's try these, okay? So we'll write a squared plus b squared equals c squared, and we'll put a little question mark there. Now, before we can do anything, we've got to make sure that c is the biggest number. So in these 3 numbers, this is c, that's a, and that's b. But over here, this is the biggest number, so that has to be c, then a, then b. So be careful. They try to trick you a little bit. And we'll pop this in. 36 squared plus 48 squared Does that equal 60 squared? We'll find out. And this one we put 4 squared plus 5 squared. Does that equal 7 squared? 7 squared. We'll find out. Okay. So let's take our nifty calculator. 36 squared and 48 squared and 60 squared. So, oops. Let's try that again. 36 squared is 1,296. 48 squared is 2,304. This is 3,600. I'm going to add 2,304 plus 1,296, and it's true. I get 3,600 equals 3,600. So yes, this is a right triangle. Let's try the other one. 4 squared is 16, and 5 squared is 25. Does that equal 49? 16 plus 25 is 41. That does not equal 49, so you cannot build a right triangle. You can build a triangle, but not a right triangle. So that wraps up lesson 1. I hope you learned quite a bit, and always good luck.